In one of our previous classes, a student brought in his Nissan Almera with a drivability complaint, basically performance issues. Now, this vehicle is what we consider to be a local. That means it is not foreign, so it does not have the upstream and downstream oxygen sensors, which we will usually look at to see our fuel trims in order to determine if we have a fuel restriction or an air restriction somewhere. So our normal diagnostic method cannot be applied. So therefore we have to look at other sensors carefully to see if we could pick out any discrepancies. Example, throttle position, mass airflow, air temperature, etc. And this is what we found. Stay with us. Now everything looked normal at first. There's no fault codes. But looking at our sensors closely, the mass airflow sensor stood out. The idle voltage across this sensor was 1.3. Now usually 1.3 is associated with RPMs closer to 2500. But this car was idling at 750, 800 RPMs. I'm looking for something closer to 1 volt or even less. So that made us look at this sensor even closer. With use of our oscilloscope, this is what we found.
Before I ever see this before, in some Toyota vehicles, understand vehicles to more high performance, that have a flap on the intake manifold to change the direction of the air when it's coming in. So what has happened now, they had the intake runners. More thin and long the intake runner is, more fast the air will come in at a faster speed. So more faster you fill the cylinder. But you don't get much top end performance because when you start to reach higher RPMs, you just get enough volume on it. But higher RPMs, the runner switch from being that long intake runner to a short runner like that. We can accept a greater volume of air instead what the engine needs. So when we idle here and we snap, this, watch how high the voltage rate, this is how much air coming rush through the MAF sensor really quick. So we have a high acceleration of air coming in there. So we create a strong vacuum. So the body open, remember, at this point the body barely trapped. And then four cylinders try to pull air through that little trap. So it's a strong vacuum, you know? Vacuum, right? When you pull out what's that back and it crumple, strong vacuum. So that way we get this acceleration here. It's very good. However, when we reach here now, at this point it starts to drop. Why? Because since the throttle body open, enough atmosphere coming and equalize that pressure. So no longer this high acceleration of this high velocity air. It basically slow down. But because we keep the throttle open, it starts to accelerate again. So the typical MAF sensor waveform is exactly what you're seeing here. Go down back, this is the snap. So high acceleration of air, throttle body open, it equalizes the atmospheric pressure, the cylinder full, it went down, but because we keep accelerating, it started to go back again. Typical, which is good, typical. But you see all this here, never seen so much. And that is a concern. From my experience and cross-referencing waveform, this is not a good sense. It's not a good sense. It's just too much noise here. So all this here, something happening. The signal not.
So guys, as I explained, that was the typical response for a mass airflow sensor. But there is too much noise on that sensor signal, guys. And I don't think it's anything with the signal itself. I think it's just the sensor is faulty and producing all that excessive noise. Now, fortunately, we did have a sensor to replace it. And immediately, we see a difference in voltage and a difference in signal. Take a look at this.
How that signal looking? Much cleaner. Much cleaner. You guys see nothing like?
Yes. We ain't got the notice for it.
I start from up. Drop out of 2 hours this time. But that's how clean that signal is. You see it? Wait. Wow!
And there you have it, guys. Much cleaner signal trace and a much cleaner sensor signal shown on the oscilloscope. We did get some improvement in performance, but obviously other things need to be checked since this does not have an O2 sensor, which is required to trim fuel. Again, thanks for joining us, guys. Here at Diagnostic Plus, we turn data into answers, and we hope we demonstrated that for you. Until again, take care, Diagnostic Plus.